Ever wonder why your smart speaker sometimes sounds like it's yelling, "Hello," in Japanese? Or why AI voices occasionally stumble over words that should be simple? The answer lies in the complex world of text-to-speech systems. And today, we're diving into how researchers are solving one of the trickiest challenges: Japanese pitch accents. Modern AI voices rely on massive models called large language models, LLMs, to generate speech. These systems are incredible at sounding natural, but they struggle with languages like Japanese, where a single word's meaning can change based on pitch. Japanese uses kanji, Chinese characters, and kana, phonetic symbols, and its pitch accents, like a musical scale, can completely alter meaning. Traditional systems handle this by converting text into phonemes, but newer LLM-based approaches skip this step, treating text as raw letters or even bytes. This makes them versatile for multiple languages, but leaves them clueless about nuanced rules like Japanese accents. Enter UtterTune, a breakthrough from researcher Shuhei Kato. This system doesn't retrain the entire AI, which would be computationally expensive and erase its existing skills. Instead, it uses LoRA, low-rank adaptation, a technique that acts like a tiny, customizable plugin. Imagine modifying a car's engine without rebuilding the whole vehicle. LoRA tweaks just a few parts of the model to teach it new tricks. Here is how it works. You add special tags, fon start and fon end, around tricky words. Inside those tags, you write the word using kana, Japanese phonetics, and mark accents with apostrophes. For instance, fon start Japanese letter slash Japanese letter, Japanese letter, Japanese letter, Japanese letter, Japanese letter, fon end. Tells the AI to pronounce Chinese letter, Chinese letter, Chinese letter, Chinese letter, evil spirits, with the correct pitch. This method preserves the AI's natural voice and multilingual abilities while fixing pronunciation errors. Tests show UtterTune boosts naturalness from 3.44 to 3.88 on a 5-point scale, and slashes pronunciation errors by nearly 50%. The update: a tiny file, less than 0.5% of the original model's size. It's efficient, effective, and keeps the AI's voice identity intact. This isn't just about fixing accents. It's about giving creators control over AI speech, enabling more accurate multilingual voices. Next time you hear an AI speak, remember, behind the scenes, tiny tweaks like UtterTune are making it sound just right. Thanks for watching. If you want to explore how AI learns to speak, hit subscribe. Until next time, keep exploring. To test these systems, researchers use stress tests, challenging scenarios to push AI to its limits. One test used 50 everyday Japanese sentences, crafted with AI tools like ChatGPT to avoid common pitfalls. They fed these into a pre-trained model called CosyVoice 2, which sometimes struggles with complex sentences. Instead of retraining the model, they applied LoRA, a targeted tweak that lets the AI learn new skills without forgetting its existing ones. For the second test, they focused on words with tricky pitch patterns. By adding fon start and fon end tags, they gave the AI a cheat sheet for hard-to-pronounce words. Success was measured using naturalness, how human-like the speech sounded, and CER, character error rate, a spelling test for speech. UtterTune improved naturalness by 13% and cut errors in half. These results relied on real-world data from corpora like JSUT and JVS, which contain hours of Japanese speech. Metrics like VoiceMOS, a human-like rating of synthetic voices, ensured the AI's voice stayed authentic. The key takeaway: even massive models can be fine-tuned for specific languages with minimal effort. So the next time you hear an AI speak, remember, it's the result of years of research, clever algorithms, and mountains of speech data. These advancements aren't just about making machines talk, they're about making them communicate in ways that feel human. And that's just the beginning.